It's going to form a solid gas, a snowball of solid gas that we call dry ice. The reason it's called dry ice is that when it melts, it doesn't go into a liquid, it goes straight into a gas again. So we say it sublimates or sublimes. So this is carbon dioxide in here. And there's a couple of other interesting properties about carbon dioxide. I can show you that using some water. And I've also got some universal indicator here. You may have already used this in chemistry. And what you'll know is that when you add it to water, it turns a green colour to show that it's a neutral solution. So it's not an acid, and it's not an alkali. But we will change this again. We're going to make it into an alkali. I'm going to add an alkali called sodium hydroxide, which is usually used as a cleaning agent in sinks. I'm going to add around about 200 mils, so not too much. And that's going to change the colour of our solution, or rather the indicator in the solution. So when we add an alkali to universal indicator, what colour does the indicator go? Bluish, yeah, purplish. So purple, blue, depending on the strength of the alkali. Remember, red for acids. And you'll see all of this a little bit clearer because I'm going to pour it into my giant test tube here. And then what I'm going to do is I'm going to get that carbon dioxide to bubble through. And what we'll do is we'll do that by dropping the carbon dioxide inside. And I'm just going to pop some gloves on because the dry ice here is going to be at around about minus 78 degrees Celsius. So it's pretty cold. And if I hold on to it a little bit too long, what will happen is it will start to freeze the skin cells on my hand. Give me a little bit of a frostbite basically. And they won't recover, they'll just kind of die off. So rather than that happening, I'm going to protect my hands just a little bit. And what we should have now is our solid snowball of carbon dioxide gas. There we go. You might notice that white mist, that's water vapour. I'll tell you a little bit about that in a minute, because actually the gas itself is colourless, it's invisible, so we can't see it. So what we'll do is we're going to pop this into a little bag, just so that we can then drop that inside our liquid. And it will start to bubble through our alkali. Now remember, the alkali has been coloured with a universal indicator. So if that changes, we should see the indicator change as well. So here we go, just drop that through. And it will start to bubble away. Now remember, that white mist isn't the carbon dioxide. What it is basically, I'm going to overspill a bit. What it basically is the coldness of that carbon dioxide cooling water vapour in the air down into tiny little droplets of fog. The rest of the bubbles of the carbon dioxide are bubbling up and through the column, and lots of them are escaping, but some of them are actually dissolving in that liquid. And if you keep your eye on the colour of the alkali, or rather that liquid and the universal indicator inside, you'll see that it's changing. So the carbon dioxide, as it dissolves, as it bubbles through the liquid, is actually neutralising our alkali. And we can see that it's getting weaker and weaker because it's starting to go a more blue colour. And look, we've gone past green and we're starting to go yellow. So in fact, we've completely neutralised it, and now this is slowly turning into an acid. Now that's quite important because we find carbon dioxide in lots of things. And in particular, you find it in fizzy drinks. So maybe over the Christmas period, you might indulge in a few too many.